Now that we've had a chance to review some properties of exponents, we can introduce the concept of an exponential function. An exponential function is one that takes on the following form. This will be f of x is equal to a times b raised to the x power. Now there are technically a couple different ways that this can be written. It can also be written as a times b raised to the x power with parentheses around the b to the x to indicate that that's happening first according to the order of operations. This can also be written as a times b inside parentheses raised to the x power. One thing that this definitely does not mean is that the a does not go inside the parentheses. This is not the same as the previous ones. The idea is, according to the order of operations, we do the exponent first and then we multiply by the a afterward. So b in this case is referred to as the base of the exponential. And two things have to be true about it. B has to be a positive number and b cannot be equal to 1. If b is a negative number, then occasionally we could run into raising a negative number to a fractional power, and if that fraction happens to be 1/4 or 1/2 or 1/6, we run into some issues because we want to make sure that we're dealing with real numbers, not imaginary numbers. Additionally, if the base is 1, then 1 raised to any power is just going to be 1, and that turns the exponential function into something really boring. A is what's referred to as the initial value. And the reason that we refer to it as the initial value is because the y-intercept is always going to be the ordered pair 0, a. And the fact that there's a 0 in here is what makes it an initial value. We usually start at 0. So the reason that this works the way that it does is for a y-intercept, we set x equal to 0. So for our exponential function, that would be a times b raised to the 0 power. Now we know from our review that we just did of those exponentials that b raised to the 0 power, that's going to wind up being equal to 1. And then a times 1 will be simply a, letting us know that when x is 0, y is a. And that's why we call it our initial value. Additionally, for exponential functions, they fall into two categories. If b is greater than 1, we did say about b it has to be greater than 0 but not equal to 1, which means that b falls into two categories. If we mark off 0 and 1 here, put open circles at 0 and 1, then there are two different categories that b can fall into. One of them is where b is greater than 1. This is referred to as an exponential growth function. Now, we'll get into this in more detail in the next section, but an exponential growth function tends to start off very low to the x-axis, and then it starts growing very, very quickly as soon as you've crossed the x-axis. Once again, that y-intercept is going to be right over here at 0a, wherever a happens to be. Additionally, b, since it's positive but not equal to 1, could also fall into the category of being between 0 and 1. In this case, this is referred to as an exponential decay function. For an exponential decay function, it looks like the mirror image of the exponential growth function through the y-axis. Once again, we'll see a 0a here for the y-intercept. Now, both the exponential growth and decay functions, they have asymptotic behavior on one side. There's a horizontal asymptote on the left side for the exponential growth, and there's a horizontal asymptote on the right side for the exponential decay function. Again, more detail on that in future sections.